Okay, so now let's move to 10.2. We have superposition of wave. At the end of this chapter, you should be able to state the principle of superposition of the wave for constructive and destructive interference. Use the standing wave equation where y is equal to a cos kx sin omega t, and discuss progressive and standing waves. For 10.2a, you have to state the principle of superposition of wave and use it to explain construction and destruction interference. So here is the definition for superposition. State that whenever two or more waves are traveling in the same region, the resultant displacement at any point is the vector sum of their individual displacement at that point. So example, we have positive amplitude plus positive amplitude, so then you will have two amplitude. This one is positive amplitude and negative amplitude, so then you will have zero amplitude for resultant. This is interference. Interference is an interaction or superposition of two or more wave motion. So we have two types of interference. First we have constructive. The constructive is the resultant displacement is greater than the displacement of the individual wave. So this is the example. So we have y1 plus y2 and the resultant is here. The resultant is in the green. Okay, in green, no, the yellow one. Alright, so this is the resultant which we have more or greater than individual displacement. It occurs when y1 and y2 have the same wavelength, same frequency and in phase. And then this is the GIF image to show the constructive interference. So we have y1 plus y2, and then for the resultant we have the greater displacement. This one we have destructive interference. What is destructive interference? The resultant displacement is less than the displacement of its individual wave or equal to 0. So consider we have y1 is positive amplitude and y2 is negative amplitude. So then the resultant is 0. Y1 and y2 has the same wavelength, same frequency, but empty phase. So then we will have destructive interference. Destructive interference, we have positive amplitude at this point, okay, negative amplitude. So then you can see the GIF image shows that the sum of the resultant we have equal to 0. So contoh kat sini we have, okay, equilibrium, so 0. Positive amplitude, negative amplitude, okay, 0. Negative amplitude here, but positive amplitude you have 0. So this is 10.2b. You have to use the standing wave equation where y is equal to a cos kx sin omega t. So this is the derivation for standing wave or stationary wave or standing wave equation. So what is standing wave? Standing wave is the summation of the two progressive waves that have same frequency, same amplitude and speed, but traveling in opposite direction. The first one is to the left and the second one is to the right. So we can use the identity of trigonometry to have the equation for standing wave. So y is equal to y1 plus y2. So using your trigonometry equation, so then you will have y is equal to 2a cos kx sin omega t, where k is wave number and omega is angular frequency. This is the equation for standing wave, where we have y is equal to 2a cos kx sin omega t. 2a is the maximum amplitude of the stationary wave. A is the amplitude of individual progressive wave, and 2a cos kx is the amplitude of standing wave of a particle at x. So you have to remember this is the equation you have for standing wave, or we can say stationary wave. Alright, so this is also the equation for standing wave. So here you have y equal to a cos kx sin omega t, where a is the amplitude of standing wave. Actually, it is 2a, where this a, as I said before, this a is the amplitude of individual progressive wave. Okay, so kita boleh gantikan y equal to a cos kx sin omega t. Okay, so you will have this one. Okay, so now let's move to stationary or standing wave. At the end, you should be able to explain the formation of stationary wave. Alright, so what is stationary wave? Is a form of wave which the profile of the wave does not move through the medium. It is formed when two waves which are traveling in opposite direction, in which have the same speed, same frequency, same amplitude, are superimposed. Okay, these two waves are the progressive wave that traveling in opposite direction. For example, consider a string stretched between two supports that is plugged like a guitar. So it will have notes and antinodes, where node is a point at which the displacement is zero, where the destructive interference occur, and antinode is a point in which the displacement is maximum, where the constructive interference occur. Alright, so ini namanya adalah nodes. Alright, so this is also nodes where the zero displacement. And then for antinode we have maximum displacement. Alright, so here we can see the distance between nodes and antinodes is lambda over 4, and then between nodes and the other nodes we have lambda over 2, and then here from nodes to nodes we have lambda. Alright, the distance between adjacent nodes or antinodes is lambda over 2. Alright, so the distance between antinodes, this antinode and this antinode is lambda over 2. And the distance between node and adjacent nodes, okay, and adjacent antinodes, yang di sebelah ni tu adalah lambda over 4. Alright, so then the lambda is the distance between adjacent node or antinodes. Okay, we go to question 10.3. Where the transverse wave travel along a stretched string, we have speed of 80 meter per second and the frequency of 200 Hz. Stationary waves are produced on the string. Determine the distance between two consecutive nodes. Alright, so we find the lambda first. So we have the velocity is 80 meter per second and the frequency is 200 Hz. So from equation we can find lambda, where lambda equal to f or v over f. So the v is 80 and the frequency is 200 Hz. So we have lambda is 0.4 meters. Okay, 0.4 meters. So the distance between nodes, okay, two consecutive nodes we have. Alright, so the distance between two consecutive nodes, kita buat sini. Okay, this one is nodes and this one is also nodes. This one is also nodes. Okay, so you can see here the distance here is lambda, which is 0.4, but the question asks to find the distance between two consecutive nodes. So from nodes to these nodes, so we have lambda, okay, lambda 0.4 bagi 2, okay, divide by 2, so we will have the distance between two consecutive nodes is 0.2 meters. Okay, So 1/2 lambda. So we have 0.2 meters. Alright, so here we have to find the distance between nodes and antinodes nearest to it. Alright, so again we have the wave is like this. So we have this one is 0.2. Okay, so this one is nodes and this one is also node. This one we call the antinodes. Alright, so the distance between the nodes and antinodes is 0.1. Okay, when we have 1/4 lambda, so equal to 0.1 meters. Okay, so now we go to the explanation for the equation for stationary wave. Remember that the stationary wave equation is y is equal to 2a cos kx sin omega t. Okay, so what is meant by a cos kx? A cos kx is the amplitude for any point along the stationary wave. It is called the amplitude formula and its value depends on x distance. Alright, so we have antinodes. What is antinodes? Antinode is a point which has the maximum displacement. So we have a cos kx equal to a, so cos kx equal to 1. So we have cos kx equal to shift cos 1. Okay, so remember to press your calculator and make sure your calculator in radian mode. Okay, radian mode, and then you will have 0. Okay, shift cos 1 you have 0, and then untuk dapatkan yang kedua tu, alright, so kita tahu kat sini. Alright, so we have this one, right? Okay, so we have antinodes. Antinodes is here. This one is also called antinodes, where the distance between antinodes and antinodes is we have the pi. Okay, pi radian. That's why this one, okay, 0 plus pi plus another pi will we have 2 pi, and 2 pi plus pi we have 3 pi. So kx is equal to m pi, where m is 0, 1, 2, 3. So your kx, okay, your kx is equal to m lambda. So we have here kx is equal to m pi. Okay, so we know that k is equal to 2 pi over lambda, x is equal to m pi. So x equal to m pi lambda over 2 pi. So x is equal to m lambda over 2. Okay, so we have here x is equal to m lambda over 2. Alright, so now I will explain again in the exercise given. Alright, so we go to node. What is node? Node is a point with minimum displacement. Minimum displacement is 0. So we have a cos kx equal to 0, and then you have kx equal to shift cos 0. Alright, so bila kita tekan calculator, make sure your calculator in radian mode. Alright, so if you press the calculator, shift cos 0, we have pi over 2. Okay, pi over 2, and then again we know that the distance between nodes and nodes, okay, we have nodes here, nodes and nodes. This one is also node. This one we have pi radian. Okay, pi radian. This one kita tambah pi kat sini. Tambah pi untuk dapatkan yang kedua. So tambah pi lagi. Alright, so we have kx, okay, kx is equal to n pi over 2. So then we know that k is equal to 2 pi over lambda, x equal to n pi over 2. So x equal to n pi over 2, okay, times lambda over 2 pi. So then x is equal to n lambda over 4. Okay. Alright, so for sine omega t, determine the time for antinodes and nodes, okay, same as kx, okay. So for antinodes, again, we have the point with maximum displacement equal to 1. Right, so we have a, okay, sine omega t is equal to 1. Right, so we have omega t equal to shift sine 1, okay. So the same step as above, yeah. So we will have our t, okay, for t. So now we have our omega t is equal to n pi over 2. We know that omega is equal to 2 pi over t equal to n pi over 2, okay. So your t is equal to n pi over 2 times t over 2 pi. So t is equal to n t over 4. Okay, same as this one also. Okay, remember that nodes is a point with minimum displacement, okay, 0. So the same step, and then we'll have t is equal to mt over 2. Okay, don't worry, I will explain in this question. Alright, so example 10.4, we have two identical waves are traveling towards each other. So we have y1 is equal to 5 sine 2 over 5 pi t plus 2 over 3 pi x. Okay, y2 we have 5 sine 2 over 5 pi t minus pi x. Okay, so to identical wave, this one is the progressive wave. Okay, remember, how can the stationary wave produce? When the two waves with the same amplitude, same frequency, traveling in opposite direction will produce a stationary wave. Okay, so using stationary wave equation, we have y equal to 2a cos kx sine omega t. So y equal to 2, a is 5 cos 2 over 3 by x sine 2 over 5 by t. So your equation should be 2 over 3 by x sine 2 over 5 by t. So this is your equation for stationary wave. Okay, this is the equation for stationary wave. Okay, certain number 1b. Alright, so b, the amplitude. Okay, amplitude of particle at meters. Okay, at x equal to 2.6 meters. So we have y equal to 2a cos kx sine omega t. We have y equal to 10 cos 2 over 3 by x sine 2 over 5 by t. So remember, to find the amplitude, we only use this one. Okay, we only use this one. So we have y is equal to 10 cos 2 over 3 by your x is 2.6. So your y is 6.69 meters. Okay, C. Okay, let's see. You have to find the position of nodes. Okay, position of nodes and nodes. Okay, remember that nodes is the amplitude of particle is zero displacement. Okay, remember zero displacement. So we have 2a cos kx equal to 0. So cos kx equal to 0 over 2a, so it should be 0 lah. Okay, so kx equal to cos, shift cos, and then press your calculator. Don't forget, this one must be in radian mode. So you have your kx. Okay, your kx equal to 1.57. And then kita tahu once again, nak bagi tahu kat sini nodes, right? Nodes. Okay, so distance between nodes and nodes, sini we have pi radian. Okay, so 1.57 plus pi, you will have 4.712, and plus pi again, you have 7.85. Okay, or in pi you will have pi over 2, you have 3 pi over 2, and 5 pi over 2. So to find the x, okay, to find x, so you have k is equal to 2 over 3 pi x1 equal to 1.57. So x1 equal to 1.57 times 3 over 2 pi. So your x1 is 0.75 meters. So this is the position for first nodes. Okay, you find for the second node, you have 2 over 3 pi x2, 4.71. Okay, so x2 equal to 4.71 times 3 over 2 pi. We have 2.25 meters for nodes number 2. Okay, for the position on nodes number 2. And then for nodes number 3, pi x3 equal to 4.7.85. Okay, 7.85. So you will have your x3 equal to 3.75 meters. So the position of nodes is, for the first one you have 0.75, nodes number 2 2.25, and nodes number 3 is 3.75 meters. Okay, and then to find the empty nodes, okay, this one is position of nodes. Okay, we find the position of empty nodes. Okay, for the position of empty nodes, okay, position of empty nodes. Okay, remember the empty node is the maximum displacement. Okay, maximum displacement, so we have 2a cos kx equal to 2a. So cos kx equal to 1. So kx equal to shift cos 1. So kx equal to 0, and then 0 plus pi, you have 3.146.28, and then 9.52. Or in pi, you will have 0, pi, 2 pi, 3 pi. Because the distance between empty nodes and the empty node nearest to it is we have pi radian. Okay, we have pi radian. So your k is 2 pi over 3 x1 0. So this one is the position of the first empty nodes, 0 meter. So to find x2, you have pi. So x2 equal to 3 pi over 2 pi is 1.5 meters. To find x3, 2 pi x3 over 3 equal to 2 pi. Okay, this one. So x3 equal to 3 meters. So this is the position of x1 0 meters for empty nodes, x2 is 1.5, and x3 is 3 meters. Okay, x3 is 3 meters for empty nodes. Alright, so the last one we have to calculate the speed. Okay, calculate the speed of the wave. Okay, put it here because we don't have the space. Right, so for D we have V is equal to F lambda. Okay, so to find F, you have to find omega. Okay, so your omega equal to 2 pi F, and omega is, your omega is here, omega this one. Okay, 2 pi over 5 equal to 2 pi F. So your F is 1.5 hertz. Okay, 1.5 hertz, remember. And then the other one you have to find lambda. Okay, we got from K, 2 pi over lambda. Okay, our K here is 2 pi x. Okay, no, 2 pi over 3 equal to 2 pi over lambda. So lambda is 3 meters. Okay, so your VF is 1 over 5, lambda is 3, so we have 3 over 5 meter per second, or you can have 0.6 meter per second. Okay, let's move to 10.2c. You have to discuss progressive and standing wave. So this is the differences between progressive and standing wave. Okay, the first one is the progressive wave is produced by a source of disturbances in medium, but the stationary wave is produced by the superposition of the two identical waves that moving in opposite direction. Okay, remember that the progressive wave transmit energy. Alright, for stationary wave does not transmit energy. Progressive wave profile moves from the source, but this one for stationary wave does not moving as it fixed in the region. For progressive wave, we cannot find the nodes and antinodes because all the particles vibrate. But for stationary wave, nodes are found because the particle does not vibrate. All particles from progressive wave have the same amplitude, but for stationary wave, particles between two adjacent nodes vibrate with different amplitude. Neighboring particles vibrate with different phases, but for stationary wave, particles between two adjacent nodes vibrate in phase.